Okay, let's see if it works this time. Yes. Okay, I think it's working. Okay. So anyway, talking about a median, we have seen and talked about medians being in the middle of the road. Now we are going to talk about medians of a triangle. So let's begin by sketching a triangle. You can draw any triangle you want. I'm going to draw a triangle that looks like this just because I want to try to emphasize that it works for any triangle. It doesn't have to be equilateral. It does not have to be isosceles. It doesn't have to be anything special. There's just a triangle there. Okay, so median means middle. What's another geometry word that we've talked about that means middle? Okay, when we bisect something, and a bisector goes through the middle or the midpoint, right? Okay. So I am going to pick one of the vertices, so a vertex, and then I'm going to pick the middle of a side that I'm going to connect to that, okay? Now if I pick a side over to the left, it's not going to really connect well because it's the side of the triangle. As well as to the right here, it's not really going to connect well either. So I'm going to go across the triangle. I'm going to find the middle or the midpoint. How do I know that that's the middle? For sure. I could measure it, or if I want to label it, I just label it with little tick marks that show that those two sides are equal. That lets me know that it's the midpoint. I am going to connect the vertex to the midpoint. That is the median. So, median of a triangle is just a segment that connects a, bless you, vertex to the midpoint of a side. And specifically, it's an opposite side or the side across from it. Okay, now in a triangle, we have three vertices, which means that we have three medians as well. So now I'm going to start from this vertex, and I'm going to go to another midpoint. Here's the midpoint of the opposite side, so it's somewhere in the middle. I'm going to put little tick marks so I know for sure it's the middle. And I'm going to use 2 tick marks instead of 1 so that we know that it's different from the other side. And then we're going to connect. Again, that is a median. And then finally, I will take the final vertex here, the third vertex. I'm going to put the midpoint on the side opposite of it, and I'm going to put 3 tick marks on each side to show that those are equal, but they're different from the other sides. Connect the vertex to the midpoint. So all 3 of those in red, blue, and green are medians. So 3 medians in a triangle. Okay, now what do you notice about the 3 medians? Yeah, they meet. What's another word for meet? Intersect. Okay? This point right here where they intersect is called a centroid. So it's kind of like the center, but it's not exactly the center. So we're not going to use the word center, but it is where all the medians intersect. So, bless you. The point where the 3 medians intersect. Questions so far? Okay, so let's go down to example number 1. It says in triangle STR, draw the median from S to its opposite side. So since it says from S, that means that we're going to start at that vertex. And then we're going to go to the midpoint of the opposite side. So the side across from it, we have to find the midpoint. I'm going to mark it congruent on each side so that I know for sure that that's the midpoint. And then I'm going to connect. Questions on that? Okay. Yes. It's a segment, yep. Okay. So now for the theorem intersection of medians of a triangle, I want you to ignore all of those words right now. And I just want you to look at this little diagram that I'm going to draw, okay? I am going to sketch a segment. And I'm going to divide it into 3 equal pieces. So there are 3 equal pieces of this segment. They have the same length. So you can say that I divided the big segment into what? 3, right? What's another word for 3? I divided it into thirds, right? Okay, or try, yeah. So I divided the big segment into thirds. So if this is 1, 1, and 1, because they're all equal, the entire segment would be how long? 3. The entire segment is 3. I divided it into thirds, so it makes 3 equal pieces of 1. So then, if this right segment, this far right segment, is 1/3, if I combine these two, that is 2/3. Together, it's 3/3 of the whole segment, right? Okay. So that's what we're doing today. We're dividing these medians into thirds. So what this theorem is saying is that AP, right here, is 2/3 of the entire segment. Of this entire thing right here. Okay, so let's see what this looks like if we actually do an example, because I think it's a little bit easier than doing it above with the theorem. Okay, so take a look. It says E is the centroid of triangle ABC and DA equals 27. Okay, now first of all, because we are told that E is the centroid, that means that all of those segments in the middle of the triangle are medians. Okay? So it says that DA is 27. Let's divide that into 3 pieces or into thirds. We get 9, right? Okay, now we're going to have a small piece of the median, and we're going to have a longer piece of the median. The small piece of the median is 1/3, so it's the 9. The longer piece of the median is 2/3. So instead of 9, it is going to be 18. Because remember, 9, 9, 9 will give us the 27. So if we have 9 for the short, the long one has to be double it, because instead of 1/3, it's 2/3. You can verify that 9 plus 18 is 27. Okay? So we take the big segment, 27, we divide it into 3 equal pieces. The short segment is just one of those pieces, and the long segment is twice that. Does that make sense? Okay. So let's look at example 3. P is the centroid, so you know those are all medians of triangle QRS. RP is 10. RP is 10. Now RP is part of this median right here. Is it the long part or is it the short part? What do you think? It's the long part, right? The long part is always double the short part, so what does the short part have to be? 5. So, if we wanted the length of RP, they gave us that. RP is 10. PT, the small part, is 5. So what is the entire median? RT? 15. So you could double check your work and take the whole piece, 15 divided by 3, and say, oh, okay, 5 and 10 does work. It makes sense. Good on that? Okay. Checkpoint. The center or the centroid of the triangle is shown. Find the indicated lengths. Just try checkpoint number 1. Okay, so for this one, they give you the entire length of the median. So BD is 24. We want the pieces of the median, so we're going to take that 24, we're going to divide it by 3, and we get 8. That means the shorter piece of the median is 8, and the longer piece of the median is 16. Together, it verifies that 24 works. Questions on that one? Okay, try 2 and 3. Okay, so for number 2, they give you IJ. IJ is 4. That is part of the median IG, so we need to find JG. Well, if 4 is the small piece, how long is the long piece? 8. And the length of the entire median IG is good. And then for number 3, OL is 20. That's the longer part of the median. So the shorter part of the median has to be 10 in order for the long piece to be double. The entire median, NL, is 30. Questions? Okay, last thing I want you to do, I want you to sketch a triangle. And then pick a side to draw a median to. And I'm going to say that the length of this is 6. I'm going to call this, whoops, I don't know what just happened there. I am going to call this A. Goodness gracious. I'm going to call this B, and I'm going to call this C. I want you to find the length of BC, and I want you to find the length of AC. So we've got questions on whether or not AB is equal to BC. Are these congruent? Yes. Why? Because I told you that the segment here in the middle is the, no, I didn't call it a bisector. It goes to the midpoint because it is a median. That's right. And a median is a segment that goes from the vertex to the midpoint. Okay? Because I told you this is a median, you know that this is the midpoint, which allows you to assume these segments on either side are congruent or the same length. So how long is BC? And how long is AC? 12. Okay? So if you're on the outside of the triangle, you're working with midpoints, but if you're on the inside of the triangle, working specifically on the medians, that's when you're talking about the thirds. Does that make sense? Any questions?
Can you go back to the notes for this one?
Over to here? Here?
No, I go back to